Good morning, everyone. In today's session, we'll be discussing on division on sign magnitude numbers. In the previous lecture sessions, we had seen different algorithms for multiplication, multiplication for sign magnitude numbers, and multiplication for 2's complement numbers. Right? So this one was Booth's algorithm, and this is your normal binary multiplier. So, today we will be discussing on division, but division will be again looking at only on signed magnitude numbers. Okay, in your syllabus, we are going to study only this part, not on 2's complement number. So now, first of all, let us quickly start off with I'll first show you the hardware configuration of this hardware, what would be the hardware components required for performing division on signed magnitude numbers. This method is also known as restoring method. I'll let you know why. But first of all, let us see the hardware. It's same as the one which you had seen for multiplication on signed magnitude numbers. Let me see if I have it over here. Yes, it is. So here again you will be requiring the same hardware architecture. This one, register B, register A, register Q, a sequence counter, binary complementer and parallel adder. You will need 3 flip-flops, BS, AS and QS for storing the sign. Okay, I'll show you a neater version. I'll simply write it and show it to you so it's better for you to understand. So we will have three registers B, A and Q. In B, we will be storing the divisor. First of all, when I write like this, 45 divided by 9. This 45 is known as dividend and this is known as divisor. Okay, so for this algorithm, as per this algorithm, what we'll be doing is we'll be storing our divisor in B, that is 9, and in A and Q together. In two registers together, we'll be storing our dividend, that is 45. Is that clear? Okay. Apart from these three registers, we have E, our flip-flop, SC, sequence counter, and the complementer and adder, which we'll be using for addition and subtraction. Apart from this, we will have three flip-flops, BS, AS, and QS for storing the sign bit of all the three registers. As it is sign magnitude division on sign magnitude numbers, we have separate flip-flop for storing the sign, and in the register B, in the register AQ, we will be having the magnitude part only. Okay, so this thing I have already explained to you in the previous lecture sessions. Now let us quickly, so this is what about the hardware that would be required. Now let us quickly see the algorithm for division. Okay, so here as I told you, first part is initialization, where we will be storing the divisor in B, dividend in A and Q together. Now, as in the previous algorithms also we had seen that all the registers B, A and Q would be of the same size. So here in this example, suppose 9 is what? 1001. What is 45? 32 plus 8, 40. 48 plus 4, 44. 2 and 1. 1, 2, 4, 8, 16, 32. 32 plus 8, 40, 44 and 45. Yes. So this is my 45 and this is 9. Now, as I told you that my registers B, A and Q would be of the same size. Okay, so this 9 is my divisor. This divisor here is of 4 bits. So what should be the size of A? A should also be of 4 bits. Q should also be of 4 bits. So my dividend total should have how many bits? 8 bits. Okay, 4 plus 4, 8. So what you will do is 1, 2, 3, 4, 5, 6. So we will append two zeros on the left hand side so that I can make this 8 bits. Okay, now let us quickly write this 1, 0 and 1, 1, 0, 1. So this part would be in A and this part would be in Q. So this is how you will be writing the values of your dividend and divisor in AQ and B respectively. If you start it off wrong, the entire algorithm would go wrong. Okay, so make sure that you place the number of zeros properly. Now, after doing this, after this first step, as this is division on sign magnitude numbers, we need to calculate the sign of my final result. My result here is my quotient. Okay, when I perform 45 divided by 9, 9 5s are 45, remainder is 0. This is known as quotient. Okay, so what would be the sign of the quotient? If both the numbers are positive, the sign of quotient is positive. Is one is negative, the other is positive, the answer would be negative. So what would be the sign here? The sign of my quotient would be QS is equal to AS XOR BS. So what is QS? QS is the sign of your final quotient. Okay, and A and B are your this part and this part. So XOR of these two would give you the sign of your quotient. So that is the first step. Now here they are initializing your sequence counter with n minus 1, assuming that your sign bit is present in the register itself. But if we take this separately, what would be the value of our sequence counter? It would be the number of bits in my number. Okay, till now whatever we are doing in the previous two algorithms of multiplication, similarly here also what we'll do as the number of bits, how many number of bits do we have in our divisor? All the three registers would have same number of bits. So here we have 1 2 3 4, so 4 bits would be, we will initialize the sequence counter with 4. Itna understood? Okay, now the next step is what we need to check for overflow. Now let me first tell you what is overflow. So this first step we have understood. Okay, this is for identifying the sign of my final answer. Next is checking for overflow. First, let me tell you what is overflow. See, after completion of this entire algorithm, your final answer would be stored in A and Q. We are going to take three registers B, A and Q. Your final result, your quotient would be stored in Q and your remainder would be stored in A. Initially, as I told you, we will start with dividend in AQ together. But as we complete the algorithm, like in your multiplication one, your final product was in AQ together. Here, what we will have in our quotient would be in Q and remainder in A. So now, let us see this. Suppose I have a number like this. I'll show you what is overflow first. Suppose I have a number like this 100,110. Okay, 3 3. So this is my A, this is my Q. Now I want to divide this with 101. Suppose. Okay, so this is which number? 1 2 4 8 16 32. So 32 plus 1 2 4, 4 plus 2, 38. Okay, this is 38 divided by 5. Suppose you are given this type of number. Now, if you want to move ahead for division of this number through restoring method, it will be possible only if there is no overflow in it. What does overflow mean? Here, for checking the overflow, what we will do is we will uh, see the first, this is A, this is Q. We know that all the registers would be of same size. So here 3 bits and here also 3 bits. This is your B. Okay. So what we will simply check, if A is greater than or equal to B, there is an overflow. Now what is overflow? In this case, is A greater than or equal to B? No. This is 100, that is 4, and this is 5. There is this here, A is not greater than B, and hence there is no overflow. But if I have an example like this, let me not take this because there is no overflow here. I'll show you one example where there is overflow. I'll tell you what does overflow mean by this example. Suppose instead of this, my A is like this. This is my A. Now what is this? 1, 2, 4, 8, 16. Okay, this is 16 divided by, sorry, not 16, 2 4 8, 16 32. 32 plus 16, 48. Okay, 48 divided by 5. Now these are my numbers. Now here if I check A is greater than B, is A greater than B? What is the value of A? 110. What is 110? Yes, 6. And what is B? B is 5. Is A greater than equal to B? Yes. So there is an overflow. We cannot perform division here. Now, what do you mean by overflow? This is 48, this is 5. What will 48 divided by 5 give me? 9 5s are 45, remainder is 3. So what is my quotient here? 9. 9 means what? 1001. My quotient here is of 4 bits. But as I told you that after completion of this entire algorithm, my quotient should be of how many bits? 3 bits, because after completion of this algorithm, A will store my remainder and Q will store my quotient. Now in this case, as all the registers are of 3 bits, I cannot store 9 in my quotient, and hence division is not possible over here. There is an overflow. Okay, so how did we check this? If my A is greater than or equal to B, there would be an overflow. Your quotient will always be of size 3 plus 1, or जितने भी size का register है plus 1. You will not be able to store your final answer in your queue, and hence there is an overflow. If your if if the first case which we had taken, suppose you this is the case, okay, you have all zeros over here, 1 and 4 times zeros. So what is A here? 4. And what is B here? 5. So in this case, there will not be any overflow. Let us check why. What is this? 1, 2, 4, 8, 16, 32. 32 divided by 5. 5 8s are, sorry, 5 8s are, 5 6s are 30. So what is my quotient? 6. Will I be able to store 6 in 3 bits? Yes. So in this case, my quotient is going to be 3 bits only, which I'll be able to store in queue, and hence there is no overflow. Okay, so before we start off with the algorithm, the first thing is, first you set the sign of your quotient. Then the next step is what? Check for overflow. If there is an overflow, do not move ahead. What is the condition for overflow? How would we check overflow? A should be greater than or equal to B. One more thing we check generally is divide by zero error. Okay, what is divide by 0? Your divisor should not be 0. If you check overflow condition, by default, this divide by 0 is also checked. Why? Because if my divisor is 0, your A is always going to be greater than or equal to B. So always it would generate that, it would result that there is an overflow. Right? So by checking overflow, ये भी check हो जाएगा और overflow वाली condition भी check हो जाएगी. That quotient should be of the same number of bits. Okay, so this is what the second step, checking for overflow. Now this is your shortcut method. Just by looking at this A greater than or equal to B, you will get to know whether there is an overflow or not. So if there is an overflow, don't move ahead, stop over there, just mention that DVF, division overflow flag, is equal to 1. Okay, but you have to show this overflow checking procedure in your example. That how would you do? You simply perform A minus B. Okay, this is a step which you need to do. आपको देख के पता चल जाएगा कि there is no overflow or whether there is an overflow or not. Okay, but here what you have to do is you have to show this through a procedure. How would you show it through procedure? Simply perform A minus B. How do we perform A minus B? A plus 2's complement of B. After doing this, whatever answer you get, store it in EA. If the value of E is 1, there is an overflow, so stop. And if the value of E is 0, there is no overflow. So now what we will do is restore the value of A. यानी आपने A minus B सिर्फ check करने के लिए किया. You got some answer C here, right? But after that you got to know that there is no overflow here. तो ये जो हमने B को subtract किया था, we need to bring A back to its original position. So if I add B again over here, will I get A? Yes. So what we are doing is simply, if there is no overflow, add B back to your A. Okay. And where will you store it? You will store it in EA. अगर आपको carry मिलती है, store it in E. But we are restoring after subtraction. Subtraction, why did we do subtraction? To check whether there is an overflow or not. After subtraction, if there is an overflow, we stopped. But after subtraction, if there is no overflow, we are restoring the value of A back. And hence this algorithm is known as restoring algorithm. Not only in overflow, हम आगे भी algorithm में बहुत सारी बार subtraction करेंगे, right? But after subtraction is just done here for checking purpose. If it's not possible, then what we will do? We will again restore the value. Okay. Chalo, now let us move ahead and see the next step. So overflow checked. If overflow is there, don't move ahead. If there is an overflow, move ahead. Let me go back to the flowchart only here. Then we'll see it through example and it would be more clear. Okay. So this part, left hand side of our entire flowchart is for checking whether there is an overflow or not. Check the value of E after subtraction. If it is 1, there is an overflow. DVF is 1 and stop. And if E is 0, so what we are doing is A plus B वापस करो, restore the value and set the DVF to 0. After that, move ahead to the right part of the flowchart. Here, what is the first step? Perform shift left. Shift left on EAQ. Next, perform subtraction. Shift करके subtraction करो. In subtraction also we will check the value of E. If E is 0, after subtraction, whatever answer we get, store it in EA. And if E is 1, whatever answer we get, simply store it in E. Okay? We'll see this further. The subtraction करो. Subtraction के बाद check the value of E. If E is 1, Qn is 1. And if E is 0, restore the value of A. ठीक है? See, generally what we do when I perform this type of subtraction, 1, 0, 1, 1, something, divided by 1, 1. What we do is, पहले हम subtract करके check करेंगे. Is this thing possible? This is a smaller number, this is a bigger number. So we do not write anything over here, right? We will not be able to perform this division. तो subtraction करके check किया कि नहीं, this number is smaller than this. So what we will do is check the next one. ठीक है? तो हमने क्या किया? After subtraction, we got to know that I'll not be able to perform division of 1 0 divided by 1 1. So what I'll do is I'll restore the value of 1 0. मैं इसको वापस plus 1 minus 1 1 जो किया था मैं उसमें वापस plus 1 1 कर दूंगी and I'll get 1 0 back. Then I will check with the third number 1 0 1 divided by 11. This is possible? Yes, it's possible. So what did we do? We placed a 1 in the quotient. Right? So here also what we are doing is we are simply doing the same thing. We are checking this. अगर ऊपर वाला number नीचे वाले number से छोटा है, if this is smaller than this, what we will get? We will get E to be 0. Right? And if this is bigger, we will get E to be 1. So in that case, here, after shifting, what we are doing is we are performing subtraction. Subtraction करने के बाद we are checking the value of E. If E is 1, quotient में 1 डालो. Set Qn to 1. But if E is 0, what we will do is we restore the value of A. जो मैंने subtract किया था check करने के लिए, I will add it back and it will result in EA. So what we are doing is A plus B. Okay, so this is the algorithm. The algorithm is very simple. If you look at the steps, check for overflow, then perform shift left, then perform, after shift left, perform subtraction, check E. If E is 1, set Qn to 1. If E is 0, A plus B karo. This is your algorithm in brief. Okay, now we'll see with an example and it would you'll get to understand it clearly. Okay, let us take this example. How to solve it? 448 divided by 17. Okay, let us quickly complete this. First of all, 448, let us convert this to its equivalent binary. It is 111 and 111 6 times 0. This is 448 and 17 is 16 plus 1. Okay, so now first step is write the binary of both the numbers. Now see how many bits are there here. 1 2 3 4 5. So my B is 1. Now A and Q together will be storing this. Dividend in AQ and divisor in B. Okay, so if this is of 5 bits, my dividend should be of 10 bits. So arrange this in 10 bits. ये मेरे कितने bits हैं? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now last 5 bits here, 1, 2, 3, 4, 5 will come in Q, and first 5 bits I'll place a 0 here. Okay, so 0, 111, 0. This would be in A and this would be in Q. This is the first step. इतनी यहाँ पे mistake नहीं होनी चाहिए. Okay, this is my entire number 448. So last 5 bits I am placing in Q and the first 5 bits in A. After that, let us check the sign. QS would be BS XOR, नहीं अपना our final result, yes, quotient BS XOR QS. So here both the numbers are positive, so 0 XOR 0, and my final result would be 0. So my quotient would be positive. Okay, so this much is done. Now let us start solving the algorithm. Here first of all, what we will do is we will need E, A, Q, SC. Okay, first of all, initialize the values. Dividend कहाँ पे, इधर पहले डिवाइजर भी लिख देते हैं. डिवाइजर B equals to 10001. Now here as per our algorithm we will also have to do subtraction. मुझे A minus B भी करना है, A plus B भी करना है. So for that let us also take B bar plus 1, so that whenever we will have to do subtraction we will add this value. So what is B bar plus 1? This one as it is, 2's complement of B, this one as it is, and then flip the bits. Okay, so these two things for our reference we have kept over here, so that it can be used in the algorithm further. Dividend in AQ. So right now हमने अभी A और Q की values लिखी. Let us write it over here in our tabular form. So A is 01110, Q is 1, 2, 3, 4, 5. So this is my first step. Okay. After that, let us check for overflow. Overflow was the first step to be checked. Okay, so for overflow what we have to do is check overflow. For overflow, what is the first thing we will do? We will check A minus B. So subtract B from this. Subtracting B यानी ये वाला part add करो. What is this? 0, 111, नहीं 4 times 1. A minus B कर रहे हैं अभी हम, ठीक है? 0, 1, 1, 0, here 1, 1, 1, 1, 1, 1, 1 here and 1 here. Carry 0. So here E equals to 0, therefore division overflow is equal to 0. As E is 0, there is no overflow. Okay, so if there is no overflow, restore B. So अब B इसके अंदर add कर दो, 1, 0, 0, 0, 1. As E was 0, no overflow, so we are adding B back and making it original A. So 1 plus 1, 0, then 1, 1, 1, this 1 plus 1, 0, and store the answer to EA. भले E1 बन गया, ठीक है? Now, as per our algorithm, we can move ahead. ये इतना part हमने क्या किया? We just checked for division overflow. यहाँ पे sequence counter को we forgot to initialize it with 5. Okay, now let us move ahead. What was the first step? Shift left, SHL. किसको shift left करना है? EAQ को. This is our logical shift left. So this one will drop and this will come over here. 0, 1, 1, 1, 0. This Q would remain as it is. इधर as it is है, ठीक है? This 0 will come here. फिर आगे 1, 2, 3, 4 and shift left. So a 0 is inserted here. First steps SHL EAQ. After that, next step is subtract B. What is subtract B? Add B bar plus 1. So what is B bar plus 1? इधर हमने लिख के रखा है ऊपर 0 4 times 1. So I'll add that over here. 0, 1, 2, 3, 4. 1, 1, 0, 1, 1, 0, E is 1. Okay. Now, as E is 1, set Qn to 1. So, what will we have? These things would remain as it is 0, 1, 0, 1, 1. 1, 2, 3, 4. Set Qn to 1. And then decrement the sequence counter. Okay, set Qn to 1 and decrement the sequence counter. Again, repeat the same process. SHL EAQ. This one will drop. This 0 will come here. 0, 1, 0, 1, 1. This 0 will come here. Then 1, 2, 3, 1, 0. After shift left, see this thing is going to repeat. Okay. After shift left, what we'll do? Subtract b. That is b equals to add b bar plus 1. So क्या करेंगे इधर? Again add 0 4 times 1. ऐसा ही था ना? Yes. Add b bar plus 1. After that, addition would give me 1, 0, 1, 0, 1, 0 and e is 1. So here e is 1. So set q into 1. तो वापस क्या करेंगे? 1. These would remain as it is. This would remain as it is and set Qn to 1. This make it 1. Okay, and decrement the sequence counter. Next, again, so this is first time we did the same thing. Now second time. Now again third time. SHL EAQ. So this one will drop 0, 0, 0. No, sorry. This 0 came over here. Then 0, 1, 0, 1, 0, 0, 0, 1, 1, 0. Then subtract b. Subtract b is addition of 1, 1, 1, 1. 1, 0, this one will give me 0, this will give me 1, this will give me 1. And here e is 0. Other things as it is. So if e is 0, what we have to do? E is 0, so add b. What is my b? 1 0 0 1. Okay. अगर e 1 था तो qn को 1 सेट किया but here e is 0 so what we have to do is add b. It would give me 0 1 0 1 0. Okay, any doubt in this? So here what we did is we simply restored a. Okay, after doing this again repeat the same process. ये सब same रहेंगे and the sequence count would become 2. Again repeat the same process. SHL EAQ. This will become 0 1 0 1 0 1 0 0 0 1 1 0 0. Then subtract b. Subtract b is 0 1 2 3 4. 1 1 0 0 0 and e is 1. So now after subtracting e is 1. So set q into 1. The remaining things would remain as it is. Qn को हमने 1 set किया and set the sequence counter to 1. Again repeat the same thing. SHL EAQ. This one will drop 1 2 1 1 0 1 1 0 1 0. Then subtract b. Subtract b is add 4 times 1. 1 0 sorry 1 0 1. E is 0. E is 0 so what we will do? Add b. What is b? 1 0 0 1. Here we will get 0 1 1 0 0. Here q will remain as it is. After adding b, decrement the sequence counter. Okay. So after completing this thing, I reached sequence counter as 0. So this is my q. This is my a. After completion of the entire process, my quotient would be in q and remainder would be in a. Okay, so this is what, check what is 11010. Quotient 11010 is 1, 2, 4, 8, 16. 16 plus 8, 24, plus 2, 26. And remainder is 6. What was our number? 448 divided by 17. So if we check this, we will get this answer. Okay, so after restoring process, after the performing the entire algorithm, we got our final answer, quotient in Q, remainder in A. And what was our QS? QS is our sign. AS XOR BS, sorry, QS XOR VS, which was 0 XOR 0, which is equal to 0. So my answer is positive, positive 26. So this was all about restoring algorithm. The only thing is perform shift left, carry out subtraction. If E is 0, add B, and if E is 1, set Qn to 1. This is your Qn, last LSB of Q. LSB of Q is your Qn. Okay, so this was the restoring algorithm. Main thing here is you need to understand how to write the value of A, Q and B. All these three should be of same size. Depending upon the size, adjust the value of your dividend in AQ and divisor in B. Okay, I showed you two examples here. First one was we learned how to store 45 divided by 9 in AQ and B, how to store 45 in AQ and 9 in B. Okay, and then we saw this example. So by now I assume that you will understand how to start your algorithm. If you don't store your values properly in AQ and B, your entire algorithm would go wrong. Okay, and then you just have to follow this procedure. After subtraction, if you get to know that E is 0, restore the value by adding B, and if your E is 1, set Q into 1. So this was restoring algorithm.